Okay, next let's talk about accuracy and precision. So accuracy, so it actually refers to the validity of our result, and precision actually refers to the reliability. According to the definition, so what is accuracy? So accuracy is how close a measured value to the true measurements. So for example, let's say that I bought a new weighing scale from Shopee, let's say. So this is where the screen where I'm going to have a look at my weight, what is going to be my weight. Okay, for example, let's say that my weight is 58 kilos. I know that my weight is going to be 58 kilos. So I use probably I pay for the machine at the mall or something. Like I know that it should be 58 kilos. Then I'm going to try this new machine. So what I do is I weigh myself repeatedly. Okay, so let's say for the first time that I weighed myself, I'm going to be 57.8, I'm going to be 58, then I'm going to be 59.2, and then I'm going to be 60 and so on. Okay, so it's going to be called as being accurate if it's actually close to this value, because I already know that the true value is going to be this. Okay, and from the values that I have over here, so I'm going to compare so whether or not their weighing scale is actually accurate. And if I were to observe from this value, I wouldn't say that it is accurate. So it only marked 58 once. The rest is going to be 57, 59, 60, which is, so if I were to compare both of this, that's a difference of 2 kilos. The difference of 2 kilos is actually kind of big. All right. And precision, on the other hand, is how close the measured value to each other and how consistent your results are for the same phenomena over several measurements. So it's going to be the same value, but we would like to see of how close the values are with each other. So if it's going to be precise, if the value are not much difference from each other when we take the measurement repeatedly. So I'm going to demonstrate by using this game of darts. So this is actually the board, and the middle over here, so this is actually called as being the bullseye. Okay, so the term is bullseye. So this is where we want the dart to hit, right in the middle. Okay, so I have 4 chances. So for picture number A, so I have 4 chances. One goes here, 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 and here. So what happened is that I am kind of close to the mark. I almost hit the bullseye. So it's actually very accurate. I'm being very accurate to the true value, but I am not very precise. One goes to the top, one goes to the bottom, one goes to the left, one goes to the right. So that is accurate, but not very precise. Okay, for the second scenario, so my dots are kind of grouped together. It's super close to each other, so therefore it is very consistent. I am consistently so actually pointing the dots toward the toward the right bottom. Okay, however, in terms of the accuracy, so there is no accuracy in here. I am not even close to the bullseye. And for the third scenario, this is even worse. So it definitely is inaccurate. It doesn't even hit close to the bullseye, and it is all over the place. One goes top, bottom, right, left. So it is not valid and not reliable. Okay, because for this case, it's not precise. So I'm put over here. So not precise, inaccurate, and not precise. And for the last one, this is what we wanted. So the data are grouped together. So it is, and it hit almost right in the middle. So it is accurate and it is also very reliable. Alright, so now let's have a look at the scenarios that we have right here, and for each of the situation. So we're going to identify whether it's accurate, precise, or both. So for the first one, so it says you are playing football and you always hit the left goal post instead of scoring. So you don't score, it doesn't really get in the goal. So therefore what happened is that you are not accurate. But the good thing about you is that you always hit the left post. You're being consistent about it. So therefore this is not accurate but precise. So that is going to be for the first scenario. And for the second scenario, so a candy manufacturer claims that each packet contains 20 candies. So supposedly, so in each of the packet contain 20 candies. A sample of packet have 18, 21, 19, 21, 19, 20, and 22 candies respectively. So the average is 20 candies with an error of 1 candy. So the error is just one candy, so I would say that it's pretty accurate. But would I say that it's going to be precise? But I don't think it's precise, because if you have a look here, so the values kind of differ. It goes from 18 until 22, so that's a difference of 4 candies. Okay, so I would say it's accurate, but it is not precise. So C, a manufacturer claims that a chocolate packet contains 20 chocolates. A sample of packets have 17, 18, 18, 17, 18, 17, 17. You know what, this is a very bad manufacturer. So none of them is actually like close to being 20. So therefore what happened is that this is definitely not accurate. So he should start thinking of buying a new machine. That is actually one crappy machine. But is it precise? Yes, it is super precise, because the data is just whether it's going to be 17 or it's going to be 18. Super precise. So for D, in an experiment with 5 trials, the end result of the 5 trials for whatever is being tested are 35, 36, 36, 35, 36. The actual value is meant to be 42. So this is super distorted from the real value. So this is definitely not accurate. But in terms of the precision, yes, it is precise, because it keeps hitting 35 and 36. It's pretty much similar to scenario number C. And then for E, in an experiment with 5 trials, average value is 35. The actual is meant to be 35. Mean that you have 5 trials. When you add together all the values and divide by 4, you actually get a value of 35 when it is supposed to be 35. So therefore this is both accurate and it is also precise. So this is what we want to go for. Okay.